In this question, we're given a reaction energy or reaction coordinate diagram, and we're asked some questions about this reaction. The first is, does this reaction release or absorb energy? Is this reaction endothermic or exothermic? Well, if we look at this, the reactants have this energy, and the products are higher in energy. So in order to cause the reactants to form products, we have to put energy in, making this endothermic, or said another way, it absorbs energy. It says, how many transition states occur in this reaction? Well, the transition states are at the top of each of these curves. So we have 1, 2, 3 transition states. These are your transition states here, and there are 3 of them. These lower parts of the curve, which don't tend to usually be flat lines, this is more like a curve, but in this case, these are your intermediates. So we have our transition states, and we have our intermediates, and what I just said didn't make a whole lot of sense, because this is just giving you room to write the word intermediates here. So this is just your intermediates. So that's here at the bottom of this one, and here at the bottom of this one. So at the bottom of the 2 curves, you have your intermediates. Could this be an elementary reaction? An elementary reaction would be 1 step. So if this was all you saw from here to here, this is an elementary reaction. It goes from one thing through an intermediate, through a transition state to a product. That's an elementary reaction. This reaction occurs in 1, 2, 3 steps. So no, this can't be an elementary reaction. It's a 3-step reaction. Elementary reaction is a single-step reaction. If you said this could not be an elementary reaction, how many steps are there? There are 1, 2, 3 steps. There are 3 steps to this reaction. If you said this reaction could not be elementary, then enter the number of the step that is of the mechanism, which is the rate determining step. So I'm going to just call this step 1, this is step 2, and this is step 3. There's not a good way to label this, but this is 1, this is 2, and this is 3. Which is the rate determining step? Which one is going to occur the slowest? If you remember, the distance between here and here is the activation energy. The lower the activation energy, the faster the step. Said another way, the greater the activation energy, the slower the step. So if we look here, you have a very large activation energy for step 3. So this is the 3rd step of the reaction. So the one that's going to be the slowest is the one with the largest hump, or the one with the largest activation energy. So that's how you can interpret this reaction coordinate diagram. These are used all the time in organic chemistry, so this is a really important thing, a really important skill to have as you go through Gen Chem.